And away we go. So this is a short lecture series we're in the middle of, and I've titled it Field Notes from a World on Fire. And the subtitle tells you what we're talking about. We're talking about climate change and our, I guess I would say, shrinking prospects for averting global catastrophe. And today, having spoken with you last week at some length about what I called the complex but certain science of climate change, pivot to thinking about the kinds of vulnerabilities that are affecting the world today. Last week, I spoke with you about the accelerating collapse of the glacier systems on the two poles and in Greenland and Iceland, and some of the forces driving that, the way in which the sea currents are increasingly carrying warm water underneath the glaciers at the, and I should say the ice shelves to be precise. And at the same time, the atmosphere is driving these atmospheric rivers of warm, humid air into some of those ice fields. And so they're getting it from above and below at the same time. They're cracking and decomposing. And of course, the glaciers are not stationary. And so as the ice fields decay, the glaciers tend to move to the sea, to lower ground. And so we are getting accelerating melting of the glaciers. And it's not all the way there yet. We might still be able to prevent the complete collapse of the ice caps if we get our act together soon. But it certainly does seem to be accelerating. And it's one of many phenomena that once it reaches a critical mass, once it reaches a threshold, it becomes inexorable. It's impossible to stop. Or else the only way to stop it, as we discussed at the end last week, is through geoengineering, by trying to put a bunch of ships in the poles and blow the seawater back onto the glaciers during the cold of the winter in order to cause them to reform, right? And so this is just one indication that we are edging our way towards cliffs that we don't know exactly where they are. Later in today's lecture, I may show you an image of me in some very warm, very shallow water, very close to the continental shelf, where if I went another 100 feet, all of a sudden I would be in very deep, very cold water and might be in a very different situation. We don't know exactly where the climate change cliffs are, but we really don't want to find them, and we are getting perilously close to them. And so today I want to concentrate on the fact that we are increasingly living in a vulnerable world, right? A world in which we can trigger events that are existential threats to us and to biological life on the planet, that could potentially cause runaway climate change, which could take our planet out of the Goldilocks zone, where it's not too hot, not too cold, just the right temperature for biological life. And the way in which that changes our psychology, our calculus of the costs of action and inaction, or at least the way in which it should. And on the other hand, the impediments to it actually bringing about those changes. And so that's the focus for this second lecture. As you can hear, we are edging our way away from the core climate science ideas and increasingly into the economic, technological, and ultimately political ideas. And so that's the transition that we're in the middle of. I will just reiterate very briefly what we spoke about together last week, which is that we are already seeing, and it is increasingly difficult to deny, that the climate around us is changing. And so I think many of us have been deeply frustrated and also just flummoxed by the fact that there are so many climate change deniers in our midst, so many people who are unwilling to accept the science or the evidence around them, or to act on the so-called cautionary principle. If there's some chance that this is right, then how in the world can we not be acting as if it is? But I think that this is increasingly less the case for the public as a whole. Now, having said that, that doesn't mean the public as a whole in the United States, which of course is the largest contributor of greenhouse gases per capita in the world, and in a leadership position, both in terms of bearing such a large share of the responsibility, but also in terms of being probably the best hope for the world actually collaborating on a solution, it doesn't mean that our political establishment is acting with the urgency that is required. It's one thing for, as now is the case, 2/3 to 3/4 of the American public to believe that climate change is really happening, and for a smaller but still substantial majority to believe that it is human caused. It's another thing for us to actually muster the resolve to make this a high priority issue, a high enough priority issue that we are willing to make economic sacrifices and show world leadership on this issue. And so we are seeing these multiple intersecting climate change crises occurring around us: fires, floods, droughts, ice storms, hurricanes, tornadoes, as they had in Kansas yesterday in April, right? That this is happening, and it is evidence that our world has changed and become less hospitable to us, and that we need to act. That these crises reveal a world in which, although the primary driver up until this point of climate change has been the fact that human beings have been unearthing vast stores of fossil fuels deposited over hundreds of millions of years by decomposition and compression, and burning them, and hence putting that carbon dioxide that had been safely stored in the earth into the atmosphere. That's the primary cause up until this point. We are increasingly unleashing natural forces. I spoke of accelerating deep ocean currents, drawing the rot of ages to the surface around Antarctica, where it decomposes and releases carbon dioxide and methane. We spoke of the possibility of those glaciers retreating or crumbling into the sea and being replaced by less reflective material. We will speak a little bit today about rainforests and deforestation, or about the permafrost, the vast tundra of so many parts of the earth. These are all stores of natural matter that has not decayed in a way that releases the carbon dioxide, methane, and other greenhouse gases they contain. These are natural reflective surfaces. that contribute to that delicate equilibrium that maintains a fairly steady state temperature on the planet Earth. And we are now unleashing processes that change the underlying dynamics, that cause more of the carbon dioxide, methane, et cetera, to be released, cause the reflective surfaces of the poles to shrink. And once that starts, it doesn't matter, in a sense, how much carbon dioxide we release. And I need to correct myself immediately. I shouldn't say once that starts. Once that gets to be a runaway, self-reinforcing process, right? And so we are increasingly recognizing that we are in danger of causing events that once we unleash them, we cannot control them, that are not related directly to the amount of carbon dioxide we spew into the atmosphere, the amount of electricity we generate and how we generate it. That stuff we can control. Some of these natural processes, the currents in the seas accelerating or decelerating, right? And both of those things can happen simultaneously. Good luck trying to restart a major ocean current or trying to stand in its way, right? And so this is why the United Nations Intergovernmental Panel on Climate Change, as well as many individuals, are doing their utmost to sound the alarm bell, to get us to move these issues up our priority list in terms of the things we care about politically. And so to put it in its simplest form, we need to act now. If we fail to act very soon, we will be faced with forces that overwhelm our capacity to cope. And yet the kind of action we need is a kind of action, frankly, humanity has never mustered before, which is global, concerted, but deliberate and careful action. It is also action that involves redistributing resources and foregoing profit. And so economics and technology, as well as politics, are relevant to solving this problem. I pointed out to you last week in looking at the science, and again, this is just a quick review, that the Earth has a delicate energy budget, an equilibrium in which the sun provides us with heat and energy that our planet absorbs, but also re-radiates back into the solar system, and that we do that currently at a ratio that allows us to maintain a steady temperature on the surface of the planet, roughly absorbing 70% and reflecting back out 30% of that energy through complex processes that are actually self-equilibrating processes. As more heat reaches us, more heat is radiated back out, but that when we burn these fossil fuels, when we engage in other industrial processes that use petroleum products, when we have 9 billion people, it's not there yet, 8 billion, 7.7 billion people reliant on industrial agriculture, when we increasingly have an energy-intensive civilization, we put these gases that trap some of this heat that would otherwise be radiated back out in our atmosphere, and that makes our planet hotter, already about 1.1 degrees Celsius hotter than it was 150 years ago, already baked in because of the amount of carbon dioxide in the atmosphere, because of the heat trapped in the oceans, already going to reach 1.5, probably exceed 1.5 by the middle of this century, right? And so we are already in very dangerous territory. Sorry, based on the number of humans, the kind of energy we use, and where we get that energy from. We have a carbon-based world economy that is unsustainable, right? Will destroy the planet if we continue down this course. The evidence is clear, right? And I just go back to this diagram again and again to show you, right? When the level of carbon dioxide goes up, the temperature on the planet goes up. When it goes down, the temperature on the planet goes down. This is a very strong pattern of covariance, and we understand the causal mechanism. And please look at how much higher the concentration of carbon dioxide in the atmosphere is than it has ever been in human history, as far as we can tell, going back nearly 1 million years, right? And then again, just reviewing the idea of interconnected processes, right? That the Earth's ecosystems, what's sometimes referred to when we connect them all together, the Gaia system, looking at the planet as an overall ecosystem, is interconnected in ways that make it very difficult for us to understand, but on the other hand, mean that there are feedback loops, that there are self-reinforcing processes, as we looked at together last week. When we burn fossil fuel, increase the concentration of greenhouse gases, raise the temperatures, raise the sea temperature as a result, atmospheric and sea temperature going up. We then begin to melt the ice caps in the Arctic, the Antarctic, Greenland, and Iceland. This leads to a loss of albedo reflection, and this in turn warms the atmosphere again. Please note it also melts the permafrost, right, which contains a huge amount of methane and carbon dioxide. It also warms the seas, and there's a huge amount of methane frozen at the bottom of the seas, right? And those in turn release more greenhouse gases into the atmosphere, and off we go again. Self-reinforcing cycles. I didn't really speak with you last week, and I will just speak with you very briefly today about deforestation of the rainforest, especially in Brazil and Malaysia. I was looking for, I could not find the most up-to-date data, but we are in the middle of a period of mass deforestation. And you can see these satellite images in which hundreds of square kilometers are being burned and then reused for agriculture. But in addition to the slash and burn agriculture, which is typical of Brazil's farmers, we also have other processes at work, so-called desertification, the transformation of a forest into a desert, or savannification, right? Sorry, I'm making up a term, but I think you understand what I mean. A rainforest is different from a savanna. A rainforest has several layers of canopy. When cloud deposits humidity, when rain hits the canopy, it doesn't actually reach the surface of the earth. And the result is that that liquid immediately evaporates again, right? When it reaches the surface of the earth, it tends to be absorbed into the surface of the earth and becomes groundwater. And so there is less humidity, right? clouds, among other things, have very high albedo effect, right? If the sun hits the top of them, they reflect sunlight back up. In addition to them, that they continue to deposit humidity as they move along, and so they sustain the rainforest over large areas, and the more humid weather patterns that moderate temperatures, for instance, in North America and Western Europe, as a result of the vast rainforest in the Amazon. If these very delicate, intricate, complex ecosystems are destroyed, either by us burning them or by natural forest fires combined with decreased humidity, they will be replaced by areas that absorb more of the sun's heat, produce less humidity, and therefore contribute to an increase both in the overall temperature of the planet and an alteration in the weather patterns in the regions that are fed their humidity by the rainforest. And so again, just another illustration of the kind of self-reinforcing process we are potentially unleashing. Looking at this now on a global scale, and this is going back to earlier UN projections, which I find a little bit easier to read and present than the most recent information, which has become so data dense that it's a little overwhelming, right? Different scenarios, right? And from the most favorable scenarios, which involve, right, getting to zero, net zero, as they say, carbon emissions by 2030, to scenarios that involve staying on a course that we were on 10 years ago, right? Involve increase carbon emissions or decreased carbon emissions. And then that can be translated into temperature changes. And as you can see, as the concentration of greenhouse gas goes up in the atmosphere, the likely temperature increase goes up. The most favorable scenario is somewhere between 1.6, 1.7 degrees and 3 degrees, right? And as we get into the less favorable scenarios, as you can see, the temperature change is all the more destructive, almost unfathomable in terms of what it would do. Now, again, this is the earlier UN diagrams, which differentiate by region and by ecosystem the kinds of changes, both in physical systems, biological systems, and human managed systems. And then the risk level, right, rising as we go through history from basically low risk to very high risk. And right, that depends in part, especially with the human managed systems, on how successful we are at managing that risk. And very quickly, as you can see, whether we're talking about the oceans, strong risk for high risk scenarios, inundation and habitat loss, mass coral bleaching and mortality, reduced fisheries, which of course means increased hunger, And then we can look at a particular continent. As you can probably see, right, these diagrams are overlaid a map of the world, right? And so to just take Central and South America, there's a high risk of reduced water availability and increased flooding and landslides. And right, we saw that in South Africa and Durban just 2 weeks ago. We see it in Northern California with portions of the Pacific Coast Highway being washed out almost annually. And please note that this will cause migration, right? This will cause climate refugees having to go elsewhere. And the result will be then increased political instability. There's an interesting article in the online New York Times by Thomas Edsall on how population growth combined with climate change are driving more and more mass migration, and that the rate of migration seems to be strongly correlated with the level of rancor, hate, and violence in our politics. We are becoming more and more fortressed in the more and more developed parts of the world. That in turn might diminish our political capacity to solve problems that have a global dimension to them, right? And so a peculiar natural political feedback loop, but that is the kind of thing that unfortunately a more vulnerable world presents us with. By the way, looking again at the human effects in South America, reduced food production and quality, and as you can see, the risk level here is very high. And then in addition, the spread of vector-borne disease, and that's something I want to return to. So I'm just illustrating to you the kinds of global risk and catastrophe we're talking about. And then I want to reintroduce to you the philosopher who I think is doing the most interesting work trying to come to grips with what it's going to be like to live in a world that we have destabilized at both a natural and a human level. And this is Nick Botstrom, who is a professor at Oxford University, a self-described polymath. He understands the science of climate change, the science of artificial intelligence, things to do with genetic engineering as well. I think as well as many scientists do, at least as a non-scientist, it certainly appears to me that he is taken very seriously by scientists doing research in these areas, but then he's trying to think through the ethical, cultural, and political consequences of living in such a world. And he creates this diagram to suggest two dimensions that we need to be thinking about simultaneously. One of them has to do with the scope of the risk that we face, from personal to global and transgenerational, and from imperceptible to terminal or worse, right? And so he is concerned that for most of human history, the idea of global catastrophic risk has been something that we have really not had to cope with, that at most it might be that a particular culture, state, civilization faced extinction in war, or extinction due to the fact that they over-farmed their croplands and so could no longer feed their population. but the idea that we would simultaneously face global transgenerational risks that were terminal, that put us in this territory of risk, is novel. It's something that really only has become a possibility in the 20th and 21st centuries as a result of, on the one hand, the population explosion of human beings on the planet, going from somewhere around 200 million for much of human history to approaching 8 billion in a couple centuries, right? So a huge population explosion on the one hand, and on the other hand, extraordinarily accelerated technological change. And again, I think it's worthwhile trying to remember that 100 years ago, almost no human being had a refrigerator in their house or a washing machine, that most of the human population lacked electricity, but also indoor plumbing, that computers were still the stuff of science fiction, that we had not really gone through the medical revolution in antibiotics, let alone mapped the genome and then begun to be able to do genetic engineering. We really didn't even understand the structure of DNA 100 years ago, right? And so technologically, we are in this exponentially accelerated territory that also carries with it these kinds of risks. And so Botstrom is saying, in a sense, philosophically, culturally, politically, we are unprepared to live in the world we live in. And in that sense, then the frustration that those of us who are looking at climate change and saying to our political class especially, but everyone around us, wake up, the fire alarm is going off. We need to change now, or else we are doomed, that is actually something that we shouldn't be as surprised about, because as a species, as cultures, we have not had to face these kinds of issues before. We have not developed the cultural resources for thinking these problems. And here's the real rub of his scholarship. We have to develop these resources very quickly, because the world is not waiting for us to engage in a process of slow cultural evolution as we have had the luxury to do in the past. And I've spoken with you about this before. After writing this book, which is an edited volume published about a decade ago on global catastrophic risk, Botstrom published this paper a few years ago on what he calls the vulnerable world hypothesis. And it's a quite technical paper. It introduces a metaphor, which I know I've shared with you before, but I think it really gets at the real underlying issue in a way that is intelligible and powerful. And so he suggests that we are transitioning from a resilient to a vulnerable world, right? And I've spoken with you about Fermis Paradox, right? The great physicist. I believe he was at Princeton at the time in the cafeteria saying to his colleagues, you know, by any calculation, there should be a ton of intelligent life in the universe. Why haven't we seen any of it? One explanation for that paradox would be that civilization biological life eventually produces intelligent life eventually produces the kind of technological civilization we have here on the planet. Once civilizations reach that stage, we tend to annihilate ourselves, right? And I want to distinguish for a moment two different scenarios of self-annihilation. I think there's the one that Fermi was really worried about, which is what you might call fast violence, right? There are people in this world who have the capacity to launch weapons that would wipe life off the planet, right? One of them, unfortunately, is in charge of Russia right now and appears to be increasingly rattling his nuclear sabers. And so we are painfully familiar with the scenario of rapid self-annihilation via war or deliberately self-destructive consequences. But the other scenario is the scenario of slow violence. And I think up until this point, we haven't concentrated enough on that scenario. I'll give you an analogy, which is you're a drinker. You go to the bar every night. The bar you go to is rough and tumble, and there are frequent fights. Some of them are knife fights. And so your primary concern is to stay away from those dangerous people who might kill you. And it turns out you succeed in doing that. But every night you're drinking too much, right? And lo and behold, it's the alcoholism that kills you, right? You've spent all your time thinking about the fight, too little time thinking about what you're doing to yourself, even if you avoid the immediate rapid threat. And that's the problem with so-called slow violence, is that we tend to be insensitive to it because it isn't obvious. It isn't sensational, but nevertheless, gradually it produces changes, decline, decay that will prove terminal if not addressed, right? And so I think, in a sense, to be honest with you, Fermi is thinking too much of fast violence, and so is Botstrom. But here's the metaphor of what it's like to live in a vulnerable world, a world that is no longer resilient. Let us introduce the hypothesis that the urn of creativity contains at least one black ball, a technology that invariably or by default destroys the civilization that invents it. Right here, you could think of fossil fuel consumption. Obviously, Botstrom is also worried about genetic engineering or other forms of technological breakthrough. He, for instance, talks about fast, easy nukes, right? If somehow fusion got to be much easier. We can refer to this as the vulnerable world hypothesis. Intuitively, the hypothesis is that there is some level of technology at which civilization almost certainly gets destroyed unless quite extraordinary and historically unprecedented degrees of preventative policing and or global government are implemented. More precisely, vulnerable world hypothesis: if technological development continues, then a set of capabilities will at some point be attained that makes the devastation of civilization extremely likely unless civilization sufficiently exits the semi-anarchic default condition. And I think this is, in a sense, the perfect chilling description of where we are in 2022 with global climate change, right? We are still in the anarchic condition domestically. We basically let our major corporations treat the atmosphere and the natural world as the sink into which they can pour all of their refuse without having to worry about where it goes or what kind of harm it does. And it is certainly the place we are at internationally and globally, right? We can't stop Russia from taking a bite out of the Ukraine and committing tremendous atrocities in the process. How in the world are we going to stop Brazil from deforesting the rainforests? How are we going to stop China from relying on coal? And I want to be as clear as possible here. I don't think we can develop the capacity to solve these problems in the time frame required to avert global catastrophe. We have to find a different path. And as you know from my previous conversations with Matt and the rest of you, I don't believe that geoengineering is a safe alternative. And so I think this really puts us in a situation where there is only one viable path out that I see, which is research and development to do, for instance, carbon capture. And we'll talk more about this in the coming weeks, but forms of technology that could be developed in the United States and then shared with the rest of the world that would, on the one hand, let us change the mix of the energy sources, the degree to which our economy is dependent upon burning fossil fuels and carbon intensive processes. And on the other hand, to pull some of that carbon back out of the atmosphere, recognizing that by the time we get to the point where those technologies are viable, we will already have put too much carbon dioxide into the atmosphere. So with all of that in mind, let me tell you why I've come down on the side of technical solutions to political problems. As you might guess, this is not my usual tendency, but having said that, these are some of the considerations that seem to me that make it implausible to think that we will manage a political solution to the vulnerabilities that our world faces, like climate change, on time to actually succeed in managing them. So I've already mentioned that the development in technology and the scale of human civilization mean our actions carry the potential for systemic effects. And that's a little bit opaque. I should say global systemic effects that really, for the first time in human history, the ordinary actions that we engage in put us in webs of global interconnection that are changing not just our backyard, our community, our society, but the world over, right? And so that makes it harder to detect or predict the effects of our everyday ordinary action. And frankly, we don't do very well at managing politically those things that are unobvious to us, right? The distant, the invisible, and especially when those effects fall on people we have no relationship to, and hence no deep emotional connection with, whether those people are people in Africa or Asia who we just don't know and have much concern for, or those people are people who are not yet born, who are generations still behind us and who therefore we have a difficult time even imagining. In addition to that, the systems that we are changing are hard to predict what's going to occur as a result of those changes, how they will act when they are disrupted. They are highly articulated, interconnected, and therefore complex. I pointed out to you last week, right, that changes in the amount of carbon dioxide in the atmosphere have changed the atmospheric energy and hence the wind conditions in Antarctica, that is changing the global ocean flows and currents. That in turn is bringing more ancient rot to the surface, increasing off-gassing as a result of increasing upwelling as more biological matter rises from the floor of the ocean to the surface of the ocean, deteriorates when it hits oxygen, releases more greenhouse gases, and at the same time, that same current is drawing warm water underneath the Antarctic ice shelves, causing them to weaken and eventually fracture and decay, right? And the idea that carbon in the atmosphere increases energy in the atmosphere, increases winds, increases currents, causes all of that. Even the most advanced models we had for understanding what climate change was doing as recently as 10 years ago did not understand those dynamics. And so I go back to something that James Scott, the great political scientist at Yale, says, looking at rivers, which is that we tend not to understand the complex interconnected processes at work in ecosystems until we have damaged them and can then see the way in which they were working before we interfered with them or disrupted them. And so in addition to the degree of complex interconnection, there's formal indeterminacy in many of these systems, right? Which is to say, it's not predictable in advance how what happens in the oceans is going to affect what happens in the atmosphere, which in turn is going to interact with what happens on continental land masses. We are seeing new, different, varied weather patterns. And most of the people, I believe, who study this believe that this was simply not predictable, that these systems, the formal word here are stochastic, right? They have unpredictable effects. You can think about this when you set up a complex set of falling dominoes, and at some point there's a juncture where the domino's either going to hit one or the other fork. Which one is it going to hit in advance? It's sometimes impossible to know because it depends on what happened with the 100 dominoes before it, right? And so the result is, in addition to the fact that this stuff is unpredictable, that the change is also non-linear. And so the difference between 1.5 and 2 degrees Celsius climate change is not half again as bad or twice as bad. It may be 100 times worse, right? And that is because at various points, the example that's sometimes used is a cascade or an avalanche, right? What causes an avalanche is perhaps, at least proximately, the immediate cause, that last snowflake landing. If in a different scenario, that last snowflake didn't land, then maybe that avalanche didn't occur. But having said that, the avalanche is produced obviously by much more than that last snowflake landing. And we don't know exactly where these phase transitions are. When is it going to be the case that, as opposed to a gradual calving of the glaciers or a gradual melting of the tundra with its permafrost, we're going to see a rapid melt or collapse into the sea of vast fields of glaciers, or a tremendous transition from tundra to mud and lake. We just don't know. And all of this makes it very hard to plan or cope in ways that say we can go this far without doing too much damage, but let's not go any further than that. So the radical increase in the potential for processes that we unleash but cannot control is one way of summarizing all of this, right? Up until yesterday, in terms of the history of the human species, we didn't have to worry about any of this, right? What we did affected ourselves and those immediately around us. They did not have potential cascading global consequences. And so our evolved ways of thinking do not equip us to anticipate or intuitively understand these kinds of effects. And I don't have a good theory of how quickly culture changes, but clearly it depends, among other things, on what's called generational turnover, on people who didn't grow up in the world of yesterday, but grow up in the world of today, rising to positions of leadership and bringing their new experiences to bear on the institutions they inherit. And among the issues we face is that we are living longer. And so these generational turnovers in leadership are taking longer. And so again, I think this leads us to be pessimistic about the possibility for political change arriving on time to cope with the kinds of environmental and other forms of vulnerability that our technology, our sheer bulk as a species on the planet, are creating. We have forms of collective action that have evolved for a very different world. It's not just our culture, it's also our institutions that don't seem well matched to the world we live in. And so we are therefore increasingly vulnerable to unanticipated global catastrophic risks. Among other things, it's worthwhile noting, right? A scientist at UC Berkeley, in collaboration with other scientists, came up with this new CRISPR technology. By the way, she's very frightened of what the invention or the breakthrough she's in part responsible for may do to the world. And Botstrom is sounding the alarm bell. You can now order on Amazon for around $100 kits that allow you to do genetic engineering experiments in your kitchen and refrigerator, right? And that is, I hope you agree, exhilarating and at the same time very frightening possibility. We need to take greater control over our technology and the risks that attend it. And we need to figure out how to do that in a way that is compatible with privacy, liberty, democracy. But this is going to take time. We're going to have to experiment. We're going to have to learn. We're going to have to figure out how to strike balances. Obviously, at some point soon, we will talk about the fact that the world's richest man is buying the world's most influential social media platform. and who knows what he's going to do with it. Again, we have an unregulated technological infrastructure that presents all kinds of risks. We need to start thinking about how we're going to address and solve these kinds of problems. When it comes to climate change, again, I will begin, I'll end today by setting up what I want to speak with you about over the next couple of weeks. I think we are foolish to wait to develop the political capacity to solve the problem. That the best course available to us, of course, involves politics, but it doesn't involve developing a world government. It doesn't involve waiting for the political parties to decide that this is the most urgent issue. We need to do something akin to a climate change moonshot. We need to invest heavily in research and development of carbon capture technology and alternative energy sources, alternative transportation. And let us hope that over the next few years, we can make the required breakthrough. And then we need to disseminate that technology rapidly and either cheaply or freely, not only within our own country, but also to the rest of the world. And then hope that we buy ourselves enough time to begin to develop the political capacity to cope with the vulnerability of the world we have made. Wilma, go ahead. I'm done for today. And I thank you for your patience in letting me go through a long, rather complex series of ideas. Please, Wilma.
Well, first of all, your being done shows us how we're all being done. And it's even worse, I think, than your reporting, because we already see the coral reef die off and the meltings and the raising of the sea levels. And we're seeing all of that, and climate change, just our weather patterns changing. But even to going in our short-term thinking has taken us now that because Europe is cutting or wants to cut back on their consumption of Russian fossil fuels, what they're doing is the way they can replace the natural gas in the short term is by burning coal. And that's what they're planning to do now. So what do we do with all of that? And I think, by the way, we're running out of time. I think the time frame is much shorter than they've been predicting.
Yeah, and so I think we have to wait and see what Europe is going to do. There will be some burning of coal, but there may also be some rapid transition into more sustainable, renewable forms of energy, right? And let us hope that on balance, it is the second more than the first, and that the European transition to a more sustainable energy sector will increase the demand for this kind of technology, which will drive down the cost for it, which will make it more attainable for less rich countries than the Europeans, right? Please note, again, things we haven't talked about. There's an awful lot happening in the world. Marie Le Pen did not win the election, but she did get the highest level of support that she's ever got, right? The National Front in France is now perhaps the second largest political party, the second most viable political party in the country. And that's, I think, a very worrisome sign. And please note that almost inevitably, right, the effort to wean themselves from Russian oil will produce a rapid economic slowdown or recession in Europe, and that's going to fuel the flames of popular resentment against the political establishment, which is going to make it more difficult for Europe to be on the right energy path, right? And so let's have a little bit of sympathy for the politicians who are saying, let's use coal this year. As awful as it is for the planet, it may be necessary politically to keep the people in power who want to do the stuff that will ultimately save the planet, right? That's the kind of paradoxical place we are in right now. Yeah, well, I am not very often accused of being overly optimistic. Thank you for that. And I, in a sense, am not very often, in particular, in the position of being a techno-optimist. But I think we have really no alternative. I would point out to you when it comes to the coral reefs, because you raised that as well. Two things. The first is that according to the most recent Intergovernmental Panel on Climate Change report, if we keep climate change to 1.5 degrees, which they think is probably impossible, there will be sustained mass die-offs of coral reefs. If we keep it to 2 degrees, most coral reefs will simply die, right? And again, I'm learning more about coral reefs as I do the research for this. Two things I'll just mention. One of them is that 80% of ocean life spends some portion of its lifespan in coral reefs. It's a spawning ground for probably the majority of the fish in the ocean, right? And so it's very integral, again, to a complex ecosystem that we understand very poorly. The second thing that I've learned recently is that there are people in the world right now doing work trying to change the coral, right? And right, remember, coral are actually microorganisms or small animals, right? That, you know, billions of them together constitute the reefs. And they're trying to breed more resilient coral that are better at resisting the warmer temperatures and the change in the chemical composition of the oceans. And so, you know, I'm very worried about the unintended consequences of playing God with complex natural ecosystems. But it may be that the best hope for the coral reefs is that these scientists succeed in producing more resilient coral. All right, thank you for that. Obviously a lot contained in your comments. Anybody else with a comment or a question for today? Matt, are you clapping or are you raising your hand?
I'm raising my hand because I want to say a few kind words on behalf of nuclear power, which does not create carbon dioxide, just creates all kinds of radiation and nasty stuff. But and the safety problem, of course, is brought to the front when people move into Chernobyl with troops and stir up the dirt and stuff. But it's a clean type of energy, and the safety in a lot of contexts, like say nuclear submarines, has been pretty good. The other part of it is, I think I've mentioned this before. I'm just betting that the Chinese will decide that they need to solve this problem by putting a sunscreen over the Earth in very quick order with a very large nuke. And I think as a matter of engineering, it makes a lot of sense. Politically anathema for almost everybody. But on the other hand, the Chinese may be very well able to ignore the rest of the world. So that's my pitch for the nuclear solutions, both the geoengineering and the actual energy production. I know you don't like it.
Well, so energy production, I'm not opposed to, and so, it's not that I don't think nuclear energy, doesn't have its risks. Sorry, too many negatives there. It remains risky, right? And on the other hand, the risks from nuclear energy seem to be more easily managed than the risks from continuing to rely on carbon-based fuels for our energy, right? And so I think many environmentalists are in a very different position on nuclear energy today than where they were 25 or 30 or 40 years ago, right? And so I basically agree with you with that on the condition that we notice that the world's becoming a very different place, right? And so we build our nuclear power plants for the safety concerns of the 21st century, whether those are floods, as we saw with Fukushima, or fires, et cetera, right? That they need to be sufficiently safe that the other problems of the world don't then lead to breakdowns and disaster. When it comes to geoengineering, so I am inclined to think that blowing off a nuclear weapon to create the atmospheric reflective barrier is probably not the way to go, right? In part because it also creates a hole in the ozone, et cetera, and so on, right? And so that we're more likely to try to use planes or balloons or rockets to put the reflective barrier into the stratosphere. And please note that all of those methods involve a lot of emissions, a lot of greenhouse emissions to get up into the stratosphere to distribute this stuff. And so one of the problems, I think we've discussed this a little bit before, is that you become completely reliant on continuously increasing the amount of sunscreen that the planet has on it, right? And that is in and of itself a problem. Never mind that we do kind of, I know I'm speaking to you in California from a beautiful spring day in New York, we kind of like our blue skies, right? What does it do to our psychology to live in a world where the sky is never blue again? Never mind, what does it do to our agriculture, or what does it do to ecosystems that rely, for instance, on photosynthesis, right? And so it's not clear to me that it solves, that it doesn't solve the immediate problem without very quickly creating a whole bunch of other knock-on problems. Doesn't mean it won't happen, but I certainly hope we will be careful, cautious before we set down this path or rely on it. It's why I prefer carbon capture to geoengineering. Yeah, go ahead, David.
Well, given our record, it doesn't seem to me that that's very reassuring.
Yeah, I'm not going to contradict you on that, David.
Speaking of
John, go ahead.
Speaking of gloomy thoughts about nuclear, let me introduce yet another, totally unrelated, more about Ukraine, that was brought up this morning in Peggy Noonan's column in the Wall Street Journal. She says it's very likely in the next week or two that Putin is going to use, that Russia is going to use tactical nuclear weapons in the Ukraine. And she's wondering, nobody has spoken of this whatsoever, as I've noted for the last 3 or 4 weeks. It is never mentioned in the press. I guess everybody's afraid of it, but I suppose someone in the US is wondering about what we should do about it if and when it happens. And it beats me. It's not an easy question.
Yeah, I read, I can't remember where, but the Pentagon is already war planning for the use of tactical nukes, either the idea of an exemplary explosion, so you do it somewhere over the Black Sea to try to force the hand of the Ukrainians into surrender, or you actually bomb Kharkiv, right? You know, that apparently the Pentagon, the military leadership, is talking with NATO about how to respond.
I wonder what thoughts they have.
They're not sharing them with the rest of us. I don't think they want the Russians to know how we would respond. And I don't want to go too far down this path, but please note that Putin seems to be quite desperate for some sign of victory by May 9th, right? By the big celebration of the Russian victory over the Nazis, or I should say the Soviet victory over the Nazis in World War II, which is an annual holiday and a display of military might. Note that gives us about a week or 10 days, and that the Russians are completely bogged down right now, right? So really making nothing by way of perceptible gain. And so the one, I guess, cautiously hopeful thing I can say, and it's a peculiar thing to say, but the one advantage Putin has is he lives in an increasingly authoritarian or almost totalitarian society, in which it becomes very easy for him to declare victory, despite the fact that there aren't any victories on the ground. It's only a hope, but you got to hope, rather than using nuclear weapons, he puts out some kind of propaganda campaign and puts everybody in jail who contradicts it. How's that for a darkly hopeful scenario?
Either put them in jail or kills them.
Yeah, poison them, etc. Yet another use of nuclear material. Flossie, are you raising your hand? If so, you got to unmute yourself. You're still muted, Flossie.
5 seconds. The one thing that is hopeful is that it must be obvious to even a child that Marjorie Taylor Greene is an idiot, even to her own constituency. Her stupidity reaches the possible zenith or the zero. I leave you with that.
Thank you, Flossie.
At least Putin may be digging his grave in another way, but she has begun to dig her grave. So let's take some popcorn for that.
I'll say amen. And that's a good place to end today.
Yes.
Thank you, everybody. Good being with you again. Take care. And more good news next week. Talk to you then. Bye-bye.